In this particular question, it is given that the approximate value of the given expression is equals to a plus b times x for all smaller values of x. We need to then find the value of a and b. So let us begin by approximating each term of the given expression. So the first binomial expression is 1 minus 3x raised to the power of half. So we apply the binomial approximation theorem. So we'll have 1 plus half times negative 3x. So that would give us 1 minus 3 over 2 times x. Then consider the second expression or the second term in the numerator. So we have 1 minus x raised to the power 5 over 3. So that would be simply 1 plus 5 over 3 times negative x, which will be equals to 1 minus 5x over 3. Then we have square root of 4 minus of x in the denominator. So we convert it into the exponent form. So we have 4 minus x raised to the power of half. Then we need to convert the term, the first term in the binomial expression, 4 to 1. So we'll factor out 4. So we can write it as 4 raised to the power of half times 1 minus x divided by 4 raised to the power of half. So 4 raised to the power of half is simply square root of 4, which will give us 2 times 1 plus half multiplied by negative x over 4. On further simplification, we get 2 times 1 minus x over 8. Now let's go ahead and plug in these values into our given expression. So we'll have 1 minus 3 over 2 times x added to 1 minus 5x over 2 divided by 2 times 1 minus x over 8. This will be equals to 1 plus 1 is 2. And then we add 3 over 2 to 5 over 2. So that will give us 8 over 2, which is simply 4x. Oh, I made a mistake here. So this is 5 over 3. So this is not 4x. So this will be, so we add 3 over 2 to 5 over 3 multiplied by x divided by 2 times 1 minus x over 8, and we have 2 minus 19 over 6 x in the numerator divided by 2 times 1 minus x over 8. We're going to factor out 2 from the numerator, so we'll have 2 times 1 minus 19 over, so we have to divide by 2, so that is simply multiplying 2 to 6, that would give us 12. Just divided by 2 times 1 minus x over 8. So the 2 and 2 factor out, leaving us with 1 minus 19 over 2 times x divided by 1 minus x over 8. Then we take the expression in the denominator to the numerator. That will give us, this is 19 over 12. 1 minus 19 over 12 times x times 1 minus x over 8 raised to the power of negative 1. Then we apply the binomial theorem to the second expression, and that would give us 1 plus negative 1, which is n, times x, which is negative x over 8. We simplify this, and this should give us 1 minus 19 over 12 times x multiplied to 1 plus x over 8. So we have two expressions. Now we're going to multiply them using the FOIL method. So we'll have 1 plus x over 8 minus 19 over 12 x, and we're going to neglect the x squared term. So this will give us 1 minus 35 over 24 times x. Now it's given in the question that this value is equals to a plus b times x. So when you compare both sides, we'll get a value is equals to 1 and b value is equals to negative 35 over 24. Let's go to the next question. So we have the binomial expression a plus bx raised to the power of negative 2, and the expansion of this expression is approximately equals to 1/4 minus twice of x. Using this information, we have to find the values of a and b. So let us begin by considering the expression a plus bx raised to the power of negative 2. Now we have to convert this first term to 1, so we'll do it by factoring out a. So we'll have a raised to the power of negative 2 factored out. That will leave us with 1 plus b over a times x raised to the power of negative 2. Now let's expand the expression using our binomial theorem. So we'll have 1 plus n, which is negative 2, times b over a times x. We're going to neglect all the higher powers of x, and this should give us 1 over a squared times 1 minus 2b over a times x. Let's distribute 1 over a squared. So then we'll get 1 over a squared minus 2b divided by a squared times a is a cubed. Now it is given that this value is equals to 1/4 minus twice of x. So when we compare both sides, we get 1 over a squared is equals to 1 over 4. So we take the reciprocal. We get a squared is equals to 4. Then we take the square root on both sides, and that should give us a equals to plus or minus of 2. Now we compare the second term, so we'll get negative 2b over a cubed is equals to negative 3. So we multiply both sides by negative 1, and that would give us 2b over a cubed is equals to 3. So we have 2b is equals to 3 times a cubed. Since we have two values of a, let's start with a equals to 2, positive 2. Then that should give us twice of b is equals to 3 times 2 cubed. So we'll have 2b is equals to 3 times 2 cubed is 8, and we divide both sides by 2, so we get 3 times 4, which is equals to 12. So this is one of the value when a is positive 2, and then when we consider a to be negative 2, then we'll have twice of b is equals to 3 times negative 2 cubed. So that will give us 2b is equals to 3 times negative 8. We solve for b, and that will give us b is equals to negative 12. So these are the two values. So we have a equals to 2 and b equals to 12, while the other set is a is negative 2 and b is negative 12. Let's go to the next question. So in this particular question, it's given here that x is very small, such that x cubed can be neglected when compared to a cubed. So using this condition, we have to prove that square root of a over a plus x the square root of a over a minus x is equals to 2 plus 3x squared over 4a squared. So let us begin by from the left hand side. So we have square root of a over a plus x added to square root of a divided by a minus x. So we can write it as square root of a divided by square root of a plus x plus square root of a divided by square root of a minus x. Now we're going to take a, we're going to factor out a, so that would leave us with 1 plus x over a. Similarly, for the second term, we have square root of a divided by square root of a times 1 minus x over a. Then we pull out the a, that will give us square root of a times square root of 1 plus x over a plus square root of a divided by square root of a times square root of 1 minus x over a. So we can factor out square root of a from both the numerator and the denominator, and that leaves us with 1 over 1 plus x over a raised to the power of half plus 1 over x, 1 minus x over a raised to the power of half. Then we take the expression to the numerator, and that will give us 1 plus x over a raised to the power of half plus 1 minus, this will be negative half. So we have 1 minus x over a raised to the power of negative half. Now we expand it using the binomial theorem. So we will have the first term, which is 1 plus n here is negative half, times x, which will be simply x over a, plus the third term, which is negative half, times negative half minus of 1 divided by 2 factorial times x over a whole squared. Now we're going to reject all the terms, the subsequent terms, because it's mentioned in the question that x is so small that x cubed and all the higher powers of x following x cubed can be neglected, plus the binomial expansion of the second expression. So we'll have 1 plus negative half times negative x over a plus negative half times negative half minus 1 divided by 2 factorial, this is negative 1, times negative x over a whole squared. I'm going to simplify the terms, so we'll get 1 minus x over twice of a plus negative half times negative 3 over 2 divided by 2 times x squared over a squared. Similarly, for the second expression, we get 1 plus x over twice of a plus negative half times negative 3 over 2 divided by 2 factorial, which is simply 2, times x squared over a squared. Now we combine the like terms, so x over 2a, negative x over 2a, and positive x over 2a cancels out. So we add the like terms, so we'll have 2 plus, so 2 times Negative half times negative 3 over 2 will give us 3 over 4 divided by 2 times x squared over a squared. So this 2 is coming because we have added the two like terms. So we can get rid of the 2, and it leaves us with 2 plus 3 over 4 x squared over a squared, and that is the required proof. So this was what we had to check. So let's go back to the question. So it's 2 plus 3 over 4 times x squared over a squared. So we have 2 plus 3x squared over 4a squared. 2 plus 3x squared over 4 squared. Let's move on to the next question. So we have been provided with an expression and mentioned that the approximate value of it is equals to a plus bx. We have to find a and b for smaller values of x. So let us begin by first converting all the radicals into exponents and then finding the binomial approximates. So we have square root of 1 plus twice x. So this could be written as 1 plus twice of x raised to the power of half, and we apply the binomial theorem. We have 1 plus half times twice of x, which would be simply 1 plus x. Then you consider the second term, which is the fourth root of 16 plus thrice of x. So we can rewrite it as 16 plus thrice of x raised to the power of 1/4. Then we factor out 16, so we have 16 1 raised to the power of 1/4 times 1 plus 3 over 16 times x raised to the power of 1/4. So 16's 1/4 can be written as 2 raised to the power of 4 whole raised to the power of 1/4. Then we apply the binomial theorem. So we have 1 plus 1 over 4 times thrice x over 16. So this will give us, the 4 and 4 will factor out. So we'll have 2 times 1 plus thrice x over 64. Then we're going to distribute 2, and that will give us 2 plus thrice x over 32. Similarly, we find out the value for the expression in the denominator, which we have the fourth root of 1 minus twice of x can be rewritten as 1 minus twice of x raised to the power of 1/4, which is equals to 1 plus 1/4 times negative twice of x, and that is equals to 1 minus x over 2. Now let us plug this value into our given expression. So we have 1 plus x for the first expression, the binomial approximation, plus 2 plus thrice x over 32 whole divided by 2 plus thrice x. Mistake here, it's simply 1 minus x over 2. So this will be equals to 3 plus, so x plus thrice x over 32 will give us 35 over 32, 35 over 32 times x divided by 1 minus x over 2, which will be equals to 3 plus 35 over 32 times 1 minus x over 2 raised to the power of negative 1. Now we apply the binomial approximation to the second expression. So this is simply 3 plus 35 over 32 times 1 plus n times x. We have 3 plus 35 over 32. I'm missing an x here. There's an x multiplied to 1 plus x over 2. Then we FOIL the two expression, and that will give us 3 plus thrice x over 2 plus 35 over 35x over 32, which will be equals to 3 plus, so thrice x over 2 plus 35x over 32 will give us 83 over 32. Now this is given in the question that this is equivalent to a plus bx. So comparing both sides, we get a is equals to 3 and b is equals to 83 over 32. That is the answer. Let's move on to the next question. So we're given an expression and we have to prove that it's equivalent to 1 over 4 minus 17x over 384, and we have to neglect all the higher powers of x and its squares as well. So let us begin by working with 9 plus 7x raised to the power half. So we factor out 9, so that gives us 9 raised to the power of half times 1 plus 7 over 9 times x whole raised to the power of half. So 9 raised to the power half is simply square root of 9, which is 3 times 1 plus half times 7x over 9, and that gives us 3 times 1 plus 7x over 18. Let me distribute 3, then we'll get 3 plus 7x over 6. Then we consider the second expression, which is 16 plus thrice of x raised to the power 1/4. So we factor out 16, so we'll get 16 raised to the power of 1/4 times 1 plus 3 over 16 x raised to the power 1/4. So 16 can be written as 2 raised to the power 4 whole raised to the power 1/4 times the binomial approximation. By applying the binomial theorem, we have 1 plus 1/4 times thrice x over 16. So we can factor out the 4. That gives us 2 times 1 plus thrice x over 16 times 4 is 64, and then we distribute 2, and it will give us 2 plus thrice x over 32. Now we substitute these two values into a given expression. So we have 3 plus 7x over 6 minus 2 plus thrice x over 32 divided by 4 plus 5x, and this will be simply 3 minus 2 plus x times 7 over 6 minus of 3 over 32 divided by 4 plus 5x. So we have 1 plus 103 over 96 x. Then we bring the term in the expression in the denominator up to the numerator. That would give us 4 plus 5x raised to the power of -1. And this will be 1 plus 103 over 96 times x. Then we factor out 4. We have 4 raised to the power of -1 times 1 plus 5 over 4 times x raised to the power of -1. So 4 inverse can be written as 1 over 4 times 1 plus 103 divided by 96 times x. We apply the binomial theorem. So we have 1 plus -1 multiplied to 5x over 4, which would be 1 over 4 times 1 plus 103 over 96 times x multiplied to 1 minus 5x over 4. Then we FOIL the two expressions, so that will give us 1 minus 5x over 4 plus 103 over 96 times x. And we're going to reject the fourth term, that is the term containing x squared. So this will give us 1 over 4 times 1 minus 17 over 96. You can use a calculator to verify this value, times x. So finally we have 1 over 4 minus 17 x divided by 384. So let's verify. So we have 1 over 4 minus 17x over 384. So we have 1 over 4 minus 17x divided by 384. So this is proved. Let's go to the next question. So it's given in the question that the square and higher powers of x can be neglected as it is very small. Now we have to prove that the given expression is equivalent to 1 minus x over 2. So let us begin by first finding the approximate value for each of the given expression. So we have square root of 1 plus x. So this can be written as 1 plus x raised to the power of half. Then we apply the binomial theorem. So we have 1 plus half times x. So this will give us 1 plus x over 2. Then we move on to the second expression, which is 1 minus 2x raised to the power 1 over 4. So we apply the binomial theorem. So we have 1 plus 1/4 multiplied to negative 2x. So this gives us 1 minus x over 2. Then we move on to the expression in the denominator. The first expression is 1 plus thrice x raised to the power 1/6, which will be equals to 1 plus 1/6 times thrice of x, which will be simply equals to 1 plus x over 2. And the final expression in the denominator is 1 plus 5 of x raised to the power 1 over 10. So this will be equals to 1 plus 1/10 multiplied to 5x, which will be equals to 1 plus x over 2. Now let us substitute all these values into a given expression on the left hand side. So that would give us 1 plus x over 2 added to 1 minus x over 2 divided by 1 plus x over 2 plus 1 plus x over 2. Now x over 2 and negative x over 2 will cancel out, leaving with us with 2 in the numerator divided by 2 plus half of x added to half of x will be simply x. Now we factor out 2 from the expression given in the denominator, so we'll have 2 times 1 plus x over 2. So we factor out the 2 and that leaves us with 1 plus x over 2 raised to the power of negative 1. We apply the binomial theorem and that will give us 1 minus x over 2. So this is proved.